Okay, so for the next video in our series here on optimization, we have this concrete barrier we imported last video that we reduced the triangles on down to 1260 from nanite, or using from nanite's 40,000, which was not for me personally, not for my project. So we have this material instance for the concrete barriers, and the reason why this is so important is this material instance is 98.7 megabytes of our size map of our concrete. So if we look at our concrete barrier here, 98.8 megabytes of our memory, 98.7 megabytes of it is this material, 53.8 megabytes of it is MIM prop master. So we got grunge texture here, which is attributing to a huge amount, a height texture, and then concrete barriers, which is the three main textures. So I'm going to start by going to these concrete barrier textures because they're very obviously way too high of a resolution. And I'll show you that I know that because if I go to, well, I suppose technically this does depend on perspective, but if I drag out an asset into the viewport, there's something a lot of people don't know about, and I just found out about this week, called required texture resolution. So if I click on this object, and then you can see the textures that are involved with it. This is the, go in here. There we go. This is this base color texture. This is the normal, and occlusion, roughness, metallic. So if we look here, we're at this distance in this viewport size. So I'm going to make this full screen. We're not under resolution until we get, let's see how slow my camera can get here, till we're like here. So unless you're playing your game and you're focused on people being this close to this texture, which I'm going to show what it looks like lit now, that's where you start to get really bad texture resolution. But if I pull back, it's probably white by like here, give or take. So we're going to look at this again. Almost bang on. So white would have been actually a little further back from where I was. So this is where it's considered good. Good looks pretty damn good. Anything more where you start to pull back and you're getting to be green or whatever it is. Let's get to the green part. This is where you're far over where you need to be. And this is probably the distance of like most cameras playing the game and seeing an object. So I think this will let me see this again. Yeah, this is a really, really useful tool because you can play your game, you can throw something into the environment, or do this in your test environment is a better way of doing it, with something that has the same or similar camera settings to you. So you know that this is your player perspective to this object. And let's play again here. I'm going to get really close to it, pretty much being a dick about it. Do the same thing. You can tell that the texture is still clearly over. So we're going to start optimizing this, and right away I know that this is way too high. Like 4K for this object is profusely high. You could go with 512, but I think you'd start to notice some texture size difference. There is an LOD bias as well, but unless you have LODs set up, it's not going to use those MIPs. So that's the other thing, and that kind of goes into the morphs that I'll talk about in the next video. But for the most part right here, you also have, where is it? Maximum texture size. And this is a non-destructive, so you can just do this and change it back after, and you can see how much the texture size changed when I did that. So I'm going to change them uniformly because you should do that when you're changing your objects, but you don't have to. So there is some flexibility there, and I've been told that you can kind of reduce certain ones by a greater factor, and I'll show that actually like right now. So easiest way to show this is just with numbers. Or is it numbers or is it negative numbers? Maybe I just don't do it up here. Okay. I'll just do it right here. So 2048 is our next one down. And that changed our resource size dramatically. There's also some really good tools for this. RD Text Tools allows you to just right click and then like in the asset selection, you can just batch edit it, which is really, really nice. But the files are still huge. Like that is still 5 megabytes in this texture alone. So that's still too big for me personally, but I'll show you the difference in the quality afterward. Okay. 2048. Okay, so that's all 3 textures now reduced. And I'll close these just to show you. If we go back to the mesh here, check our size map. Look at our memory size, it's already down to 65.1, so that's significant gains. I'll hit play again. Walk over here right up against it, so again, as close as you would really get to it without being an asshole and pulling your camera in. Then we have a nice white texture. Well, yeah, I mean it's white right there, so again, unless somebody pulls in like this, you're not really going to have any loss there. So 2K is fine. Again, like how close do you think people are going to be while they're playing your game? So if they're like running past this object like this or something like this, might be more relevant to base your decision on that. So it's still pretty white. There is some green there, so it's not too bad. If I was to like pull away, like if this is like a background object or something like that, that's when it starts to get more green. So that's when you can start to reduce those textures more. So for example, my game is a vehicle game and everything is fairly far away from something. So I wouldn't need to have that kind of texture resolution still. If I had these kind of concrete barriers, I could get away with much lower textures. Like, let's see what we can do here. Just for the fun of it. I do not know why it's taking me so long to find them. There we go. Oops. Let's try 512 just to see how terrible it looks. Because it's also just fun to see how small you can get the size map and have it still looking like a decent asset. So from here, starting to get texture loss, but yeah, you can start to see the fidelity loss at 512 for sure. Change this back to 1024. And this all depends on the size of the object as well, because it's dependent on viewport size. So if you have more players as well, like if you have local multiplayer, your texture size can be even smaller because you have your viewport size is usually very small. It's not always. That's something you can't account for, but you know, 2K is kind of the magic because this doesn't look terrible, but it also doesn't look great. So in the case of this concrete barrier anyway, 2K is actually the magic number, which makes these concrete barriers fairly large at the end of the day. But one other thing I want to check here, because some of those large textures are like normal maps and stuff, right? So the base color looks good, everything looks good at this. We don't have any problems with our textures like that. Last thing I want to check here is normals. Let's check it at full size. Yeah. 2K is the magic number for this close of a perspective, like an over the shoulder, and getting that close. If you were to, let's check one more thing. Camera boom. Let's change this back to like, well, I don't want to go too crazy with it. Let's go, what's the original? Oh, 300, that's not very far. Let's go with 500. See how big of a difference that makes. That makes a big difference. So as soon as your camera goes back that extra like 500 units or whatever, that's when you can start to bump textures down yet another scale. And I think this is probably the most significant when you start working with things where the camera's far away, like a top-down game or something like that, where a lot of things that you import from the marketplace are going to be like meant for perspectives like this or first person when they sold the thing, and weren't expecting necessarily you to make an RTS or something with it. So yeah, this is the second part of optimization, just going over the textures, making sure your textures are good, and then that will reduce your size map. So at the end of the day, I can go through this whole thing really, really quick because it won't take me very long. What do we got here? This is going to take forever unless I go directly to the size map. Oh. I can stop the game. This video is going on a bit, so I want to try to hurry up. The other main ones is obviously just this grunge texture. Like, this is, why is that 21 megabytes for a 2K texture? Oy, oy, oy. Let's see if we notice a difference at 512. Same with the height is probably, yep. And I don't know what's making it that high. That just looks like a black texture. Ay, ay, ay. Actually, let me pull my camera back in. Is it 250? Oh, it was only 250 units. And you could bump your camera down, so that's a significant difference. Really good visual fidelity on that. And that's with much lower textures, much better wireframe. And overall, we started at 98.8 for our size map, and you can crunch this way down. Like, it depends on your game and everything like that. But 23.2 megabytes, so went down by about 75% of its size map, and didn't really lose any significant visual fidelity. So if you're more granular and really dug through a lot of this stuff, you could be really picky per your game. Or your perspective for the camera angle you got. But this should help people optimize their textures a lot. So I hope that helps some people.